in the assignment 3, you need to write a program that gets a number of strings, a number of words that are separated by a space and are followed by an end of file from user through standard input, and then alphabetically sort them using a method which I'm going to show you. It's inspired by bucket sort. And then after you sort them, then you need to print the sort of the strings out on the console, but you need to mention which word is in which bucket. So as I explained the bucket sort, you will realize what I'm talking about. What is bucket sort? Bucket sort is a divide and conquer approach for sorting. Basically, it breaks down a list that you want to sort into smaller pieces, so you can sort each a small sub list or sub piece or sub array faster. Basically, imagine you want to sort these numbers using bucket sort. Let's say you have 5 buckets. The first bucket's label is 0 to 9. That means it holds number from 0 to 9. The next bucket's label is 10 to 19. The next bucket is 20 to 29, 30 to 39, 40 to 49. Each bucket's label specifies what's the minimum and maximum values that you can store in that bucket, right? And that basically means 29 should be stored in the third bucket, as you see it's here. 25 third bucket, 3 is in the first bucket, 49 is in the last bucket, 9 is in the first bucket, 37 is in this bucket, the fourth bucket, 21 is in the third bucket, and 43 is in the last bucket, because 43 is between 40 and 49. So first you distribute all the values through different buckets. For example, as you noticed, this bucket remains empty because there was no number in the list between 10 and 19. And then you sort each bucket separately. For example, the first bucket is 3 and 9. The second bucket is empty. The third bucket is 21, 25, 29. So each bucket is, the content of each bucket is sorted separately. And then the last bucket is 43, 49. And then after you sort them, then you traverse buckets from left to right and write down their contents in a sorted fashion. So 3 and 9 are in the first bucket. 21, 25, 29 are in the third bucket. Fourth bucket is 37, and last bucket is 43, 49. So this is the sorted version of the original array, right? So that's the idea of sorting using bucket sort. But for this assignment, we're not going to use numbers. We're going to store strings in buckets, and we're going to sort them using bucket sort. And then because we want to do the sort operation without case sensitivity, in this assignment, whenever you want to compare two strings, don't use the strcmp, use strcasecmp. So the strcasecmp here is the function that you use to compare, and it's in the same library. It's in the string.h. Now let me go through data structure that you need to have. For bucket sort, you need to have a structure for bucket. What is a bucket? I can define it this way. I can say struct bucket. It has a char star min word and a struct node star head. As you can say by its name, head is going to be the head of a linked list that is going to store all the words in each bucket. And min word is the minimum possible string that you can store in a bucket, right? The maximum value or the maximum word is specified by the next bucket's minimum word. I'll explain what I mean. So think about a bucket like a structure like this with two members, right? Then what is node? Node is basically a node of a linked list. If you want to create a linked list of strings, you need a node like this, which has a char star string at the as the first member, and it's gonna have a struct node star next, but so that every node can refer to the next node. The final node refers to null. That means that the final node is the tail, and it has nothing else. So the array of buckets that you need to create for this assignment should be initialized based on the command line argument. Why do you need an array of buckets? Because as I mentioned, the bucket sort is specified this way by using like multiple buckets. So you need to have an array of buckets, right? In order to create an array of buckets for the sort operation, what you need to do is you need to parse the command and arguments. You need to see what the command and arguments is. I have specified an example here. Let's say the program is executed this way. Bucket sort is the name of the program. You need to use the same word in your makefile. Like for assignment 1 was 7sec, for assignment 2 was rail cipher, for assignment 3 it should be called bucket sort. And then the parameters I have passed is apple, carrot, kiwi, pineapple, watermelon. This 5 words that I specified after the bucket sort, as you noticed, these are alphabetically sorted because apple is before carrot, carrot is before kiwi, pineapple is before watermelon, all of that. But you need to make sure if it's not alphabetically sorted, you need to end the program prematurely and throw a fatal error so that the user knows the command and arguments are not acceptable, because the assumption is the arguments must be alphabetically sorted. And what you need to do is, based on these 5 words that you see after the name of the program in the command and arguments, you need to create 6 buckets. As you see, I have bucket index 0, 1, 2, 3, 4, 5. For each bucket, I have a minimum word. The minimum word specifies the minimum value that you can have in that bucket. For the first bucket, it's going to be the empty string. The empty string is the smallest string, which means if you apply strcmp or str case cmp on an empty string and any other string, you're never gonna get a negative value. It's gonna be you're never gonna get a positive value. It's gonna be either negative or 0. That means this is the absolute minimum string you can get, because the alphabetical order follows the ASCII code, and ASCII code of empty string. First character would be 0, and that means you cannot go lower than that. That's the minimum word. So that's why it's going to be the bucket 0's minimum word. For the other buckets, I have apple, because the first parameter was apple, then carrot, then kiwi, then pineapple, and then watermelon. What does this sequence of buckets tell me? This sequence of buckets tells me that if I find a word in the input that is alphabetically before apple, for example, it is an or any word that is alphabetically before apple, it should be stored in bucket 0. If the word is between apple and carrot, for example, apples, or even the apple itself, or maybe banana or something like that, it should be stored in bucket number 1. Do you see the head here, right? The head is null originally, which means you have an empty linked list attached to every bucket. So these linked lists are going to eventually get populated with the string of words that the user enter in the command in the standard input. Then the bucket number 2, bucket with index 2, will store words between carrot and kiwi. Bucket number 3 stores words between kiwi and pineapple. Bucket number 4 stores words between pineapple and watermelon. And bucket number 5 stores watermelon or any other word that is greater than watermelon, right? Like zebra or something. So this is the story of all the buckets. Remember, the number of buckets always going to be equal to one more than the number of arguments that you have. Like in this case, you have 5 arguments, so it's going to be 6, right? Now, I explained what min word and head is, but you can study this these 2 paragraphs that I have here. It explains all of them very clearly. Now, let's talk about how to fill buckets. If you want to, I'm going to show you basically how to sort how to do the sort operation, and the sort operation starts by filling the buckets. What we're going to do is we're going to get a string and get an input string. Let's say the input string is called input string. I'll show you a quick demo at the end. I'll show you how to basically interact with input for this assignment. You just need to use one operation to read the whole line, and then break it into smaller words, and then each word has to be stored in a bucket. So let's assume that you already have received one single word from standard input, right? So you have, let's say, one word from input, and that word is input string. First, you need to copy it to a location in the heap. Let's say copy it into word. What is word? Word is going to be the return value of this statement. Actually, I have it here. So let's say you have used malloc, strlen, and put a string +1 to get enough space in the heap for the word, and then you use strcpy word and input a string to store that input string into the heap, right? Word is a location that is safe to store a sequence of characters. And then after you do this, it's time to find an appropriate bucket and store that word into one node of the linked list that the bucket is referring to. So what you need to do is you need to store this in a struct node. You need to first create some space for the struct node. How? By using malloc. You need to just say, similar to what we had before for the word, you need to say, let me do malloc, but this time, let me write it down briefly. It's going to be something like this. Actually, I can insert a text as well. I can say, let me get a struct node star, call it a new one, equals cast to struct node star, and then malloc, and then size of struct node. You can do this, and basically it's going to give you a new node in the, or a space in the heap with the type of struct node star. And then now you can basically refer to this word by the new nodes. Word, right? What was that? It was called value or word? A string, actually. It's called a string. So you can say a string equals what? Right? And that basically means I'm going to create a node, and I'm going to put that new string, new input string into it, right? But we basically put a word in it, which is the copy of the actual input string. Now, after you do this, after you basically create a node and put a word in it, you need to store it in the proper bucket. As I showed you, for example, you can have 6 buckets, or you can have multiple buckets, right? Imagine the input word is, for example, orange, right? So you need to find out the proper bucket. Which bucket is appropriate for the word orange? If you look, orange can be placed between kiwi and pineapple because orange starts with letter O and O is greater than K, but it is not greater than pineapple. So it should be between kiwi and pineapple. So it's going to be stored at this location, right? So let's say you create like a node with the value orange and you want to store it here, right? It's as simple as inserting it in the linked list, but in the linked list that is in front of kiwi, right? But you need to be careful with these 2 points. You need to store your word or the node that you created into the linked list so that your linked list always remains sorted. That's the key part of this because you're going to do this for a bucket. So you need to place it in the linked list in a way that the node that you insert is placed in a location where it is greater than everything that comes before it and everything, and it's going to be less than everything that comes after it. For example, let's say you have already 4 elements in the linked list, right? And this is the head of the linked list in the appropriate bucket. And then, there are next values here. And then let's say this one contains letter A or word A. This one contains word C. This one contains word F. This one contains word W. And then you want to place word, for example, M in it, right? Where do you need to place it? You need to basically place it here. You need to say I'm going to traverse this linked list to find out that, the word M should be between F and W. So because, it should be alphabetically sorted. So you basically make F point to M and make M point to W, right? Let me erase that. So, right? And then this connection will be erased, right? So basically, now the linked list looks like this: A, C, F, M, W. But assume that all of these are in the same bucket, right? I'm just going to make assumption that all of these are in the same bucket. In that case, we're going to do that. So you need to first find the appropriate bucket to find out, which bucket should contain the new word. And then finally, you need to insert a node containing the bucket in a linked list so that it remains sorted. I have explained basically here in these 2 lines that how you place it in a way that it remains sorted. As you see, the node M is after nodes A, C, and F that are alphabetically before M, and it's before W, which is alphabetically greater than M. So that's how you need to do it. That's kind of sort every bucket gradually as you populate the bucket using insertion sort. That's called the insertion sort. So you don't really implement insertion sort separately. You're basically implementing insertion sort when you're populating each bucket, right? And as I said, for every node that you want to insert, you need to find some location in the heap, the same way I mentioned before, like using this malloc operation. All right. Now let me show you a final example and the output, okay? I'm going to show you an example and the output. The example that I have decided to show you was the same command and arguments, the apple, carrot, kiwi, pineapple, watermelon. So as I showed you before, you have like 6 different buckets. And let's say after the user run the program this way, the input value is going to be, this is a simple example with 8 words. So imagine you run the program by entering this command, the /bucket sort apple, carrot, kiwi, pineapple, watermelon. And then when the program starts running, you enter this sentence, and then you end it with an end of file, right? So you end your program with an end of file character, which is the control D character. And that sentence is going to be parsed by the program. The program is going to place every word into one bucket, and eventually this is going to be the output. Bucket 0 will contain 8 and A. Bucket 2 will contain example and is. Bucket 4 is going to contain simple and this. Bucket 5 is going to contain with words. As you have noticed, although 8 is not a letter, but it's considered to be a word because it is separated by a space from the previous and the next word. And also 8 is a digit, so it's alphabetically before Apple, because, you know, the ASCII code of digits are less than the alphabetical letters. So this is how the output should look like. As you noticed, you need to specify which bucket contains which value, right? So you need to say bucket 0 is this, bucket 2 is this, bucket 4 is this, bucket 5 is this. Bucket 1 and 3 are empty. That's why I mentioned them here. And this is basically you can see in the red ink, you can see all the final linked list that I have in every bucket. So 8 and A will be in the first bucket linked list, as you see. The second bucket is still empty because it's null. The third bucket would be example and is. The next bucket for kiwi, it's null. The bucket with pineapple has simple and this. And then the last one, the watermelon bucket, contains with and words. This better. So it is with and words. Of course, after the last node, we have null, right? There's a null afterward. That means, you know, this bucket, the last bucket contains only 2 words. So this is the story. That's how you need to sort them. Remember, the number of command arguments should be at least 1. And also remember that the command arguments should be sorted. When I say the number of arguments should be at least 1, that means argc should be greater than or equal to 2. The reason is if you have no command argument, then we can only have 1 bucket, but that 1 bucket doesn't really create a bucket sort algorithm. You need to have at least 2 buckets for a bucket sort algorithm. So that's why I assume that the user has entered at least 1 word in the command argument, and we use that word as a main word of the second bucket. So you have 2 buckets. If you have 2 buckets, if you have only 1 command argument. All right, and for the submission, similar to other assignments, you need to submit a zip file. The zip file should contain makefile, all the C files, and possibly any header files that you may have. You can place them there, and use the word bucket sort as the name of the program executable in the makefile. Otherwise, the Autograder cannot handle that. Let me also show you the Autograder. Okay. All right, so here is the expected output on the Autograder that I posted. If you downloaded before, download it one more time because I made a little bit of change to it. It's just, there was a typo in the header file of the Autograder. I fixed it. But this is the Autograder's expected output. I have 4 test cases in the Autograder. The first test case basically runs the program with no command and argument in that situation, then no matter what the input is, your output should look like this. You need to basically raise an error and say there must be at least one CLA. So, as I mentioned earlier, if you have no command and arguments, we cannot have more than one bucket. The second test case, the command arguments are not sorted. For example, a strawberry is greater than blackberry in alphabetical order, but a strawberry is before blackberry. So no matter what the input is, the output should be bucket sort, fatal error, CLAs must be entered in an alphabetical order. So the second test case also ends prematurely. The third one, test case number 2, has a correct sequence of command and arguments. The bucket sort, and that's the name of the program. Then apple, carrot, kiwi, pineapple, watermelon. The same example I showed you in the specification of the assignment. And then the input is, this is an example, a simple example with 8 words. And as you see on the output, you see all of the buckets. One thing you can notice here is that even the dot at the end of words is not deleted. So you don't need to clean your input. You can leave it raw with all the punctuations and all the special characters. If there's a hyphen, apostrophe, dot, comma, just leave them alone. Just don't need to worry about those. Just the words with dots considered to be one word, and it's going to be placed in one of the buckets that you have for this example. So this is the acceptable output. And then the last test case has the minimum number of buckets because you only have one word as the command and argument. So you run the program this way, bucket sort mango, right? That means you have 2 buckets. The words that are less than mango go to the first bucket. The words that are greater than or equal to mango go to the second bucket. So if the input is I'd rather go shopping than go to the gym, then you break it into multiple words. I'd was with the first one, rather go shopping than go to the gym with exclamation mark. So in bucket 0, we have 2 goes because go has a caret multiple times, so you need to place it multiple times. Then gym, exclamation mark, then I, apostrophe D. Because it's not case sensitive, then, G is going to be before I, so you need to place I at the end. If it was case sensitive, I would be the first because it was capital. But it's not case sensitive. The bucket 1 would be rather shopping than the 2. And as you see, if you consider all of these words next to each other, this is a sorted sequence of words, right? Yeah, alphabetical order. And that's pretty much it. These are all the 4 test cases. Finally, let me briefly show you how you can deal with the input for this assignment. This is going to be very simple. First of all, I have some includes and a maximum length for the input, which is 10,000. I just came up with this number as just a random large number. Then I have 2 structures. One is the node. I have typed it to node to make it easier. So next time I'm going to use it, I don't say struct node. I will just say node. And then I have another structure bucket, and I have typed it to bucket. So that means from now on, whenever I say bucket, I mean this struct bucket. And it has the same structure that I mentioned before. These are basically taken from the PDF I showed you earlier. And in the main, you need to say if the argument C is less than 2, you have to print the appropriate error and say, for example, you don't have enough arguments, there is no command arguments basically, and return with a error code. And then I didn't put the other one. The other one is if the order of these strings are not sorted alphabetically, you need to throw another error and end the program prematurely. If there's nothing wrong with the arguments, then you need to start creating that array of buckets. I didn't put it here, but basically, you can take care of it. The number of buckets is going to be equal to argc. So basically, you have to create an array of buckets. You can do this in different ways. One way is going to be this. You can say, here is my buckets, which is a bucket star buckets equal to cast to bucket star malloc, and then you say argc times size of bucket, right? And then you can allocate like this many buckets. Why this many? Because argc is one more than the arguments that the user puts after the executable, which is the bucket sort. So as I mentioned, if you have, let's say, 5 words after the executable, you need to have 6 buckets. So always number of buckets is one more. So that's exactly would be equal to the argc. So basically this is an array of argc buckets, right? If argc is 2, that would be 2 buckets. If argc is 6, it's going to be 6 buckets. And this is stored in the heap, so you can basically manipulate it without being worried about losing the space, because this is already stored in a safe place in the heap because malloc is called, right? And then maybe just to show you how to, let's say, fill out one bucket. If you want to fill out the first bucket, then you would say bucket 0 dot min word is going to be equal to the empty string. That's how you, let's say, put the min word for the first bucket. This is going to be always empty string for the first bucket, or for the min word of the first bucket. Or you can say bucket index 0 dot head is going to be equal to null, because originally it's going to be null, right? But later this is going to become, a linked list of words that are going to be placed in the first bucket. And then you can just do the rest of it yourself. And then now I just wanted to talk about this. So in order to get the standard input, right? Read the keyboard for standard input. You need to do this. You need to allocate a space, whatever space you want to allocate. I allocated max len, which is going to be 10,000, and basically use that space for the result of the fgetS. fgetS is a easy to use function to read a single line from input. You can use a scanf, you can use anything else you want. You can use get line, you can use any function that you want to use, that's fine. I'm just giving you an example. So fgetS basically gets a single line from a standard input with the capacity of max len, and then if it returns 0, that means the standard input is empty. Then that's another error, and then you end the program. You don't need to call fgetS more than once, because you only need to get one line and that's it, right? As I mentioned, the line should end with the end of file, but if the user makes a mistake and put a new line at the end, we're gonna remove that. That's not gonna be the end of the word. You basically say, if the line last character is new line, I'm just gonna get rid of it by replacing it by 0. That's a very common practice when you use fgetS, because fgetS doesn't remove the new line at the end. And then after this, what I did is strtoke. Strtoke is going to tokenize the line. I just said, let's tokenize the line with a space. The first word is going to be input string. I just printed out this message saying that the first inter word is the input string. You don't need to print it. You need to basically insert it to the buckets. And then there's another while loop after that. It says while you call the strtoke again, this time for null and white space. Why null? Because that's how strtoke works. The first time you call it, you pass the line that you want to tokenize, but after that, you don't need to pass the same line, just put null. And that's strtoke remembers the original line and it starts chopping the line with the separator space, and it gives you like piece by piece words in that string. And every time it returns an input string, if that input string is not null, that means you haven't reached to the end of the line. So you basically print next word is whatever the string is, right? And at the end, I will return. Let me run this quickly to show you how things work. Let's clear things. CD. All right. So I hope you can see this. If you don't, then I will increase the font. But this is how it works. I need to first, let's say, compile this. I do compile with GCC. Actually, I think I have makefile. Yeah, I do have makefile. So I just run my makefile. And this is the makefile for the same example. Let me save this. I forgot to save it. So let's make it again. It says I have an error. The error is because I haven't done buckets. It should be buckets, not bucket. All right. Let's clear this. So after you make file and the make is successful, then start running the program using bucket sort. For example, if you put no command argument, it should give you an error. But let's say you put bucket sort with, let's say, mango as one of the command line arguments, then it's waiting for you to basically enter the sequence of words that you want to sort. For example, I would say I'd rather go shopping than go to the gym. And then I press Control D. Or I can press new line, both of them fine, but Control D is what the assignment says. And then this is what's going to happen. You will see first inter word is I'd, because, you know, I'd. And then the next word would be rather, then go, then shopping, then go, then to, then D, then gym. So it basically tokenizes it properly. So you can use this. I'm not going to post this on Canvas. You can just get an idea by looking at this. But that's basically how you can interact with the user. But the rest of it is just storing words in the buckets, and that's it. All right. Any questions? I have a feeling that this is simpler than the first two. Because, you know, it's not too much difficulty in the assignment. You just need to store every word in one of the buckets, linked list, and it's not easy. It's not hard. I think it's easier than the first two assignments. Right. Okay. And if no question, then we can end the meeting earlier. Perfect. All right. All right. Have a great rest of your day, and thank you for joining this early morning. Bye. Thank you. Bye.